Welcome everyone to a new video about Unity and the Monte Carlo method. Let's get started. What is the Monte Carlo method? The Monte Carlo method is basically using random sampling to calculate some sort of variable or solve some sort of problem that might be difficult to solve by brute force. So you can use random samples and then look at the distribution of the outcomes of the random samples in order to calculate some value or solve some problem. What I'm doing here is I'm going to be generating a bunch of points in Unity, and using the points, I'm going to kind of methodically or experimentally calculate the value of pi. So before I actually do this, let's look at the math because math is important. Oh, what? Okay. So let's think about this, right? So we can look at we can put a bunch of random points on a 100 by 100 canvas, which is what I'm doing, and then we can look at the amount, the percentage of points that fall into a circle inscribed on the canvas, and then divide that by the area of the square upon which the circle is inscribed. So if you think about it, the percentage of points which will be inside of the circle is just equal to the area of the circle divided by the area of the square. And again, because the circle is inscribed in the square, the area of the circle is necessarily smaller than the area of the square. Um, and so basically, when I say inscribed, I just mean that the diameter of the circle is equal to the length and width of the square. So that's what I mean by inscribing the circle. So again, the percentage of points inside the circle is equal to the area of the circle divided by the area of the square. Okay, so let's move on. So formula for the area of a circle, pi r squared. This is the most common form. Formula for the area of a square is the length times the width. Now, because the circle is inscribed in a square, the length and width of the square are actually both going to be equal to the diameter of the circle. In other words, length and width can both be replaced by diameter. So moving on to the next equation, if length and width are both d, then we multiply them together and we get d squared. So our equation now becomes pi r squared over d squared. Okay, the diameter of a circle is just equal to 2 times its radius. So when we convert the diameter to 2 times its radius and we square it, we square the 2, we square the r, and we end up with 4r squared. So again, we just squared this value, 2 times r, because it's d squared, and we end up with 4r squared. So now our equation for our percentage, again, this is all equal to our percentage, is equal to pi r squared over 4r squared. Okay, so what do we notice here? We have a common multiplier in the numerator and denominator, so we just simply cancel that out. So percentage is now simply equal to pi over 4. Okay, we simply multiply both sides by 4. 4 times percentage is equal to pi. So essentially, whatever our percentage ends up being, we simply multiply that value by 4, and we get our experimental value for pi. Now, the nature of Monte Carlo simulations is that the more test points you have, the more accurate your result is going to be. So let's run through a couple here. Before we do that, I'm just going to show simply some of the code. As you can see, it's really quite simple. It's like 10 lines of actual code. The other stuff is like fluff. So we simply have a test points, which is how many points we want to test. We have our progress. We have an inside, which keeps track of how many points actually landed in the inside. So here we have a I enumerator. This actually will slow it down so we can kind of see it happening. You can definitely remove this and it'll probably run that much faster. So we instantiate a point from the range negative 100 to 100 for the x, negative 100 to 100 for the z, and it's going to be randomly inside of those points. So it can go anywhere from negative 100 to positive 100, for x and negative 100 to positive 100 for z. So that covers the whole range of our square. Only some of these points, though, are going to be inside of the inscribed circle. So, and the way we calculate that is we actually look at the formula for a circle. So if mathf.pow, formula for a circle, by the way, is x squared plus y squared is equal to r squared. So our radius here is 100. And our diameter is actually 200. So we do each clone, each point is a clone. We look at its x position, we square it, we add it to its z position, which we also square, and then if that value is less than r squared, so again our radius is 100, then we simply change the material to incircle, which is a green material, and we increment inside. Otherwise, we don't increment inside, and we just change this material to outcircle, which is a red material. At the end of this, we calculate pi, which is just going to be our inside divided by test points. So this is our percentage, and then we multiply that percentage by 4. Okay, let's get started. So we go to our manager, and let's start with 50 test points and see what we get. So it finished pretty quickly. We got 3.2. True value of pi is about 3.14159,265. So 3.2, not bad, but we can probably do better. Let's go up to 100. 2.88, pretty bad. It seems that we got a lot of outside dots here, as you can see. So it kind of underestimated it, but again, this can happen. Let's try going up to 1000, and it should be more accurate this time. 3.204, okay, pretty much as good as the first time. We probably got a little lucky. And as you can see here, we sort of start to see the shape of a circle become apparent, and that makes sense because everything inside of the circle should be green. So it should kind of start to inscribe the circle and start inside of our area. So let's go up to 5,000. This might take a bit longer. Okay. We're now getting a much clearer picture of the circle. And there you go, 3.1656. So this is our closest approximation yet. And obviously the more points you add, the more accurate it's going to get. But that's not very necessary. I think you can also do this with just the quarter of the circle. And that kind of makes it a bit simpler. But yeah, you can go ahead and figure that out if you'd like. But that's about it for this video. So I just thought it was a pretty simple thing. Unity makes it quite easy to do because it handles all of the visual stuff for you. So it literally takes me like what? 1, 2, 3, 4, 5, 6, like literally just 8 lines of code, and everything else is mainly just visual. And yeah, there you go. Hope you guys found that interesting, and see you next time.